So get them out. So yesterday we looked at some equations that were easy to solve. We graphed them, but they were easy to solve algebraically. This one is not so easy to solve algebraically. This one is a little bit challenging. It could be solved algebraically, but it's going to be easier in this case to graph it on our calculator. So, everybody's got one today, I hope, because if I look out there and you don't have one, I'm going to be very mad. Do not make me mad. I'm wearing my spirit jumper today. Xander,
Oh, yeah.
calculator.
Sorry, I was getting paper there.
He's got one. I see it, thank you. You have one? Okay, I love you people, great, good job. Okay, so let's zoom standard, zoom 6, so we got a regular window, but I can't remember how we had it before. And let's type this in. Now, the way the equation is set up right now, the best way to solve it, if we use it the way it's set up right now, the best way to solve it would be to use intersections, right? Graph each side and find out where they intersect. If you would rather find the zeros, then you'll want to subtract everything to the same side of the equation, okay? I'm going to go ahead and do it with intersections, but the answer is going to be the same regardless. Okay, so this is going to be my first equation, okay? So I need you to go to y equals, because that's where we put stuff in. Oh Lord, something's happening here. All right, go to y equals and type in the absolute value 2x minus 6. Now, absolute value is found if you go to your math menu, the button that actually says math on it, and click over to where it says NUM, number, up in the menu. The very first option is absolute value. So press it, and then type in 2x minus 3. Close the parentheses, and that is your first equation. And then our second equation is x squared. And then hit graph. Do you remember from last year that absolute values are V's? So you got a nice little V and you got a nice little U-shaped parabola, and we want to figure out where they intersect. Now, the way my calculator graphed this, one point of intersection is very clear to me. The other one is kind of sketchy up here at the top. I'm not really sure what's going on. If I want to, what could I do to help myself there? Raina? Make the Y max higher, and that will just take my graph up a little bit. So I think I'll go to my window and do what Raina said, maybe make Y max 20. Now, is it more obvious where that point of intersection is now? You see 2 points? All right, so here we go. We'll run through the first one together. So second calc, intersect. So you go to second calc, second trace, pick option 5, move the cursor till it's to the left of the intersection, press enter. Right of the intersection, press enter. Close to the intersection, press enter. And I got for my first answer -3. Did you get that?
Calculator saying invalid dimension.
Probably because we have, for yesterday, we still have that plot turned on. Sometimes that causes an issue, so let's turn it off and see if that helps. Yeah. So if you're having dimensional issues, the first thing you should do is check your plot, turn it off. I don't know why, sometimes it matters and sometimes it doesn't, but that's always something to check. Okay, now on your own, find the other one. Find the other point of intersection. So second calc, intersect, left bound, right bound. I got 1, did you? Everybody get 1? All right, I want you to try the next one with your partner. It's exactly the same thing. We're gonna use our calculator to solve this equation. So this time when you put it in, you'll not use the absolute value button, you'll use your square root button, right? I didn't change my window, I just used the same window I had before. Remember, you can always alter your window if you're not seeing what you want to see. No, life in the fast lane. So rounding off to 3 decimal places. These are the answers that I got. What about you?
Some kids ask me.
Number 8. All right, put the calculator aside for a second because now we're going to solve with the quadratic formula. So I think we reviewed the formula yesterday. Formula is a big deal for mathematicians. Oh my gosh, you have to know it, you know how to use it. So x equals, here we go, negative b plus or minus the square root of b squared minus 4ac all over 2a. If it helps you, you can always write down what your A, B, and C are, if that helps you. Plug everything in. So what have I got? Plus or minus, what is all that? Wait. 7 times 3 times 4 would be 84 plus 4. I think this is 88. Double negative is going to make a plus in there. 88 breaks down to something. Uh, 2 root 11, or 2 root 22, I mean. Is that right? How about that answer though? If I'm gonna write that down in the answer blank, is there anything else I ought to do to it? Simplify it. And when we say simplify, I'm seeing some craziness in some of your homeworks. When we say simplify, if you are going to cancel in this problem, you have to cancel, you hold the triangle here, you have to cancel from all those positions, not from under the radical, just from these positions. And if you're gonna take out a 2, this doesn't disappear, this becomes a 1. So your numerator is 1 plus root 20, 1 plus or minus root 22, and your denominator is 3. Could I have solved this on my calculator? Yep. And what would I have gotten? Some decimals like this. These are called the approximate solutions. This is called the exact solution. So anytime the directions say exact, and that happens a lot in trigonometry, anytime the directions say exact, it means leave it with a pi, leave it with a radical. Don't be typing it in on your calculator to get some decimal. Perfect, beautiful. One more in P5, here we go. Okay, so here's my building, here's the ground, here's the ladder leaning up against the building. An 18-foot ladder, so this is 18, would you agree? We're gonna assume the building's standing straight up and down, we're allowed to make that assumption. When the distance from the ground to the top of the ladder is 5 feet more than the distance from the building to the base of the ladder. So this is X, then this guy has to be 5 more than that? Yeah? How far up the building does the ladder reach? Okay. What do you think when you look at that? Pythagorean theorem. Who said that? Absolutely. When you see a right triangle, anywhere in your life, if you see a right triangle, a couple of things should pop into your head. One is the Pythagorean theorem, and the other one is SOHCAHTOA. Because usually if there's a right triangle, one of those two things is going to work for you. So here we go. What's the Pythagorean theorem say? X squared plus x plus 5 squared equals 18 squared. Please understand this is a FOIL, right? So x squared plus x squared plus 10x plus 25 equals, okay, I'm going back to when my teacher made me memorize all these. Is it 324? Yes. Is it? Where am I going here? What am I going to do with this now? Probably clean it up, get it set equal to 0, and see what happens. May need the quadratic formula for it. 2x squared plus 10x minus 299. Yuck. Is that right? Okay. I'm not going to divide by 2 because that will just make that a fraction. So I'm going to leave it the way it is and use my quadratic formula. Jacob, you okay today?
Yeah.
You a football player?
Yeah.
Okay, gonna play tonight?
Me personally, probably not.
Okay, well I know personally you're not if you're sitting on the bench going like this. Okay? Keep your head up, keep your eyes open, stay laser focused. As my friend Zach Meek said, you're not Zach Meek, that's what he says. As my friend Zach Meek says, lock in. All right, here we go. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Solving this problem, kids, I have 3 options if I'm doing it without graphing. I have 3 options. I can factor it. No way am I even trying. I can use completing the square. I don't want to do that because it's going to be full of fractions. My last option is the quadratic formula, so that's what I'm doing. I'll let my calculator do some of this arithmetic. Anybody else get that? Did I do that part right? Now, I'll go ahead and simplify this a little bit at least. I just checked on my calculator, and 2492 is 4 times 623. So I know for sure I can take a 2 out of that, right? Now, I don't know about 623. It's actually divisible by 7. But that doesn't help me out, does it? So I think this is it right here, except I can take out a 2. So -5 plus or minus the square root of 623 over 2. Beep, 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 beep. No. You can't have the negative option, because what does x stand for in this problem? A distance, right? And if you did -5 minus the square root, isn't that gonna be a negative number? So that one's out. That's what we call, anybody know what we call that? We call that extraneous. Have you heard that word before? An extraneous root is a root that you get correctly, but it doesn't fit the problem. I have to throw it out. So here's my exact answer. So if the directions said answer exactly, what is that decimally? Because probably, who's our carpenter here? John. Probably John isn't going to use that number. He's probably going to use a decimal. You have 9.98 for x, which means 14.98 is how high up the ladder reaches. Would you agree with that? Okay, so what I'm gonna do now is I'm gonna go ahead, I made a little review thing. P5 will be due on Tuesday. All right, here's a little review thing. We're not gonna do it all together right now. We do wanna run through the problems real quick. And then you're gonna take it home and look at it.
Is this for Monday?
Is that our next class? Yes. And did I give you one already? So does everybody have one? Okay, so I wanna run through the properties real quick, and then the rest of this stuff, it's only one side, I don't know what you have on the back, it's just this side, just some random review problems. I want you to spend some time with it over the weekend, and we'll take 5 minutes at the beginning of class, 5, max 5, to hit any important points. Then we're gonna take a quiz and move on to chapter, or section 6. All right, so here we go. Let's run through these properties. Number 1, A. What property is that? That's your handy dandy symmetric property, folks. The symmetric property says if A equals B, then B equals A. So didn't these guys switch sides? In the homework, you had a problem like this. I need to get those turned back too. In the homework, you had a problem like this, and some of you said commutative. I totally understand that, because the order changed, but commutative is a property of addition or multiplication. Are there any adds and multiplies in this problem? No, this is a property of equality, the symmetric property of equality. All right, what about B? Associative of multiplication. So you can abbreviate But if you're using commutative, associative, identity, and inverse, you have to have an operation attached to it. So, associative multiplication. Okay, what about C? Commutative multiplication, because the order changed. D, additive inverse. Additive inverse. When you get the identical number back again, it's the identity. Here we added and got 0. So the 8's canceled out. So that is the additive inverse. E, multiplicative inverse. Multiplicative inverse. F,
Isn't that just the symmetric?
be careful. Aren't the sides exactly the same? I mean, like, it's reflexive. That's the reflexive property. If they are exactly the same, not just equal to each other, but exactly the same, it's reflexive. Property of equality. What's G? Transitive. Property of equality. And H is? Distributive. Very, very good. All right, I'm gonna hand back, I wanna get these papers handed back to you, so you can look at these too as you're preparing for the quiz. While I'm doing that, would you look at, you said Patrick wasn't here today, right? Would you look at, the rest of this sheet, look that over real quick while I am trying to figure out everybody. Is Ellen in this class?
Yeah, right. I'm just staring up on mine. I guess. I don't know if my neighbor has it, but I don't know. He probably got ready back. I don't want to go in like not mixed, like in proper fashion. So I don't really try
Okay, we got all those back. So, quickly look those over. Did anybody find anything real quick before we jump into P6? We still have time, so we're gonna jump into P6, unless you have something you wanna ask me about. Anything on the homework that I just turned back? Or turned back before? Anything on the review sheet that you had just a minute to kind of look at and try to figure out? Life is good. All right, let's start P6 then. Here we go. All right, equal complex numbers, conjugates, powers, and what? Okay, so we know that a complex, this is a complex number. We defined that the other day, where A and B are real and I is the imaginary unit. if two of these are equal, then that means, so A plus BI equals C plus DI. If two of these numbers are equal, what do you think you can conclude from that? The only way that A plus BI can equal C plus DI is if what? What has to be true?
A equals C and B.
Bingo! A equals C and B equals D. Now, that's obvious, I hope. We're going to use that in some problems, so hang on to that thought. All right, that's the only way it can happen. The real parts have to be equal, and the imaginary parts have to be equal. That's the only way that can happen. All right, conjugate. If we have a complex number, your textbook uses the notation, the guy names them, Z sub 1, for example, is 3 minus 7i. There's a complex number. His name is Z. The conjugate of Z is denoted like this. That's called the conjugate. You've used conjugates before. Do you remember what the conjugate of 3 minus 7i would be?
3 plus 7.
3 plus 7i, very good. That's it. So how do we find a conjugate? We change the middle sign. So if Z is A plus BI, then the conjugate of Z is A minus BI, right? That's it. And then powers of I. You know that I is the square root of negative 1, and it's just I. I mean, every time we have square root of negative 1, we just put I. What happens if we square I? Then we would have the square root of negative 1 times the square root of negative 1, which is negative 1. So anytime we're doing a problem, and these do come up, you know, you'll have something like 6i squared, you're going to change it to negative 6. I squares are negative 1. These don't come up as often, but they're fun math exercises. What about I cubed? Be careful. I cubed, if you think about it, would be I squared times another I. And since I squared is negative 1, won't I cubed be just negative I? Now what about I to the 4th? That's an I squared times an I squared, which is negative 1 times negative 1, which is 1. So then the fun comes in when you have this totally made up problem, because I don't think this ever happens anywhere except math class. You have something like I to the 317th power. What's that going to equal? Break it down, because we know that every 4 i's pretty much just cancel out. They make a 1, right? So we need to know, okay, so this would be an I to the 4th, I to the 4th, a whole bunch of I to the 4ths. And then maybe something left over. And all these are just going to be 1s, so I'm going to disregard them. And I'm really interested in what's left over. So instead of writing it all out, it's probably way more efficient to do what? Divide by 4. So what that tells me is, hopefully I divided right, if Addie, you're looking at me funny, did I divide wrong?
No.
Okay, you're just looking at me funny. If I were to write this all the way out, I would have 79 of these I to the 4ths. And they're just all times each other, so that's just all going to be 1. But on the end, I would have a leftover I. So when I simplify that, it just becomes I, because all the rest of it's just 1s, right? What if there wasn't anything left over? What if it divided in evenly? Then it would just be 1. Very, very, very perfect. All right, let's do a couple quick problems. Yes. Love it. All right, so here are my numbers. I've got just 2 random numbers. And I've named them the way the textbook author names them. And we're gonna add them together. Easy peasy. What do you think? We add them together. 5 minus 2i. We basically add like terms, add the reals and add the imaginaries. Easy. How about this one? We're gonna subtract z sub 1 minus 2 z sub 2's. So z sub 1 minus 2 of those. So 6 minus 10i, would that be 2 of those? Since it's subtraction, we're gonna make sure we distribute the negative. It's like regular math. You just do it like you do all your stuff. Did you get negative 4 plus 13i? Easy. Now we're multiplying 3 of the first numbers times the second number. So 3 of these, 3 of those, times the second number. Well, what do you think we're gonna have to do here to multiply those? Foil? Yep, or distribute, whatever you wanna call it. Yes, that's what we're gonna have to do. So first, outside, inside, last. And here's where your I squared is gonna pop in, because when you multiply a 9i times a 5i, obviously you're gonna get an I squared. And we talked earlier, what's negative 45 I squared? Plus 45. Which is gonna add to your 18, right? Those are like terms, they're gonna add together and give you 63. And then those guys give us negative 3i. My math work okay? Keep an eye on me. Got time to do one more? Oh, yeah. All right, so now we got the division. So now we're gonna divide our first number by our second number. Now, first of all, peeps, see these 2 3s? You're not gonna cancel them, right? No. We're not gonna cancel anything in this problem unless this time we can cancel the square. When there are pluses and minuses involved, you can't cancel just parts. You have to cancel from the whole shebang. So what am I going to do if I can't cancel anything? We call that what?
Rationalize.
Multiplying by the conjugate. I heard somebody say rationalizing. We do this with radicals, and when we do that, we're rationalizing because radicals are irrational. It's exactly the same idea, but this is imaginary. We can't even talk about rational with it. So anyhow, here we go. Why did we do that, Lena? Do you remember?
I remember doing it last year.
Okay, why though? I'm glad you remember doing it.
So you can do something with a fraction because you can't otherwise.
Okay, so Lena's answer is because I gotta have something to do, and that is a great strategy, like in geometry, to jump in and do something, because you have to do something. But, there's a reason we do this. Yeah,
To like cancel out the i's so they become integers.
okay, so the denominator, remember that rule you have about you can't have a radical in the denominator? You have the same rule with imaginaries. You can't have an I in the denominator, because what is an I? It's a square root. They can't be down there. So we're gonna get rid of that by multiplying by the conjugate, because see what's gonna happen when you FOIL the bottom? You know this. In the FOIL, the outsides and insides are gonna cancel. And as Josie said, the denominator then is just gonna be what? These are gone. That becomes a plus 25. So now your denominator is just 34. Okay, now the top, no, it's not, nothing's gonna cancel on the top, but we don't care about the denominator. So 6 plus 10 plus 9 plus 15. So what do I end up with on the top? You get negative 9 plus 99, because this guy is a negative 15, right? All right, one more, and then we'll be done for the day. How do we do 3A? Can we do it? All right, go ahead, quickly, let's boil it, see what we come up with. That's what I got. Anybody else get 35 fours minus, yeah? Yep, all right, that'll take care of that. Go ahead and grab your phones and go back to your seats. We have